Unit 8, Day 2, Solving for Intercepts. What we're going to be dealing with for a few days, and really the topic of this unit is intercepts. What we're going to be dealing with for a little bit is talking about a linear function, okay, which, as we saw earlier, the standard form for a linear function is this right here. We're going to actually be able to graph that using its intercepts. Okay, so here we go. The way you find the X intercept, you find the X intercept by plugging in 0 for the Y value. Okay, and then you solve. So you end up with a point that looks like this. X 0. You plugged in 0 for Y, that's where the Y would normally go. So we replace that, okay, with 0. And so we get a point like this. Now if you recall, on our graphs, get a better graph. If I have a graph like this, my x-intercept, we said, was always of the form x comma 0. Okay, and the y-intercept, likewise, where we were going to find that, is we will plug in 0 for the x value, and then solve. So we end up with a point that looks like 0, comma 0, comma y. Okay. Now, then we have 2 points then, okay, and all we need to graph a line is 2 points. We plot those two, connect the 2 points to form a linear function. So let's dive into this. Number 1, determine the x-intercepts and graph. Okay, so determine the intercepts and graph. So to find the x-intercept, I'm going to put in 0 for y. So it's kind of like I did this. Well, 4 times 0 is just 0. So I get a new equation that is this. Negative 3x equals negative 12. Okay, well, if I want to solve for x, I just need to divide by negative 3. And so I get x equals positive 4, because we have this negative right there, negative 12. So x equals 4, so our x-intercept is 4, comma, let's go back. 4, comma 0. Okay, now I'm changing colors here so you can see what I'm doing here. But for the y-intercept, I want to plug in 0 for x, which is the direction we had. So if I plugged in a 0 for x, negative 3 times 0 is 0. So I get the equation 4y equals negative 12. Divide by 4 both sides to get y by itself. Get y equals negative 3. So my y-intercept as a point is 0, comma, negative 3. Okay, so if I plot those 4, 0, that indeed hits the x-axis, so that is an x-intercept. 0 to the left and right, down 3. There's my y-intercept. Let's see if I can get a line to pass through both of those points. Something like so. Notice I'm putting arrows on there because it actually is continuing in both directions. So I'm plotting 2 points, but it really continues going in both directions. My points should be perfect. My graph maybe doesn't always have to be exactly perfect, but I want to make sure I have arrows in there. I notice some of you leaving those off. Okay, you need to put those on there. It is not a line segment, it is a line. It keeps going in both directions. It's really important to me. Okay, so let's look at number 2. Alright, so for the first, I'm going to plug in a 0 for y. So I get negative 2x equals 10. Well, dividing by negative 2, I get x equals -5. So my x-intercept is -5, 0. Okay, I suppose I could go ahead and plot that. -5, 0. That point right there. Now if I plug in 0 for x, I get the equation 5y equals +10. Divide by 5. Y equals 2. So my y-intercept is 0, 2. And that's a +2, so put it right there. Now if I plot a line going through those 2 points, there we have it. Not much to it. So the one really important thing to keep track of is what you are plugging in a 0 for what. So for the x-intercept, so it's always backwards. For the x-intercept, the y is 0 because you're hitting the x-axis. Okay, you're not getting off the ground. For the y-intercept, the x is 0 because you're not going left and right. Okay, so that's really the one thing to make sure you keep straight. There's another way that I like to do this, and I'll see if I can try to point that out for this next one. So, but it really comes out to be the same thing. Okay, same idea. So I like to use what I call the cover-up method. Okay, and I'll see if I can do this with these boxes right here. So to find the x-intercept, I cover up the y, the term with the y in it. Okay, that gives me an equation. -2x, -12x equals 36. Okay, and if I solve that, I'll get my x-intercept. Okay, but then I go back and I do the same thing. I kind of undo this, my covering up, and I'll come back and solve each one of these. But if I go back, and for the y, if I cover up the x term, I get an equation, which is -18 y equals 36. If you can see, I basically did the same thing. Plugging a 0 in removes the x or the y term respectively. Okay, so doing that, blocking them off, that really does the exact same thing. So, but the good thing is you can cover up with your finger. You can actually take your finger and cover those up. You don't actually have to write anything. So go ahead and mark that off. But that's another method that I like to use. So if I solve this first equation I got, divide by -12, 12, so I get x equals -3, and so -3, 0. And if I solve the second equation that I've got, divide by -18. Now another thing to make sure you notice is that we cannot lose any of these negative signs ever. If whatever's in front of the y, there's a minus sign right there. All right, there's a minus sign right there, so I have to keep that. Same sort of thing with this one right here. I had to keep that -12 over there. I'm trying to color code this so that you can keep up with it later if you need to look at it. So feel free to use 2 different colors or even use your highlighter that you could have picked up as you came in the door. I do this, let you use it for a reason. All right, but if I work that out, I get y equals -2. So my y-intercept is 0, -2. Alright, so we've got 2 points. -3, 0. X-intercept, 0, -2. Our y-intercept. And let's see if I can get a good point here. Not perfect. My lines really never are perfect. But I would like to. If you use your straight edge, you will get a much better probably looking line than I do. That will make sure they go through those 2 points. Okay, we're going to do one more of these, or I'll do one more of these and you can do it with me, and then I'll have you pause the video for the next one so that we can kind of gauge how we're doing on this. Okay, and as I always say, if you're doing this at home, feel free to pause the video and work a problem ahead of me, or think about how you do it and then watch, because learning is not about what you see someone else do. Math, I have my poster on the wall that I love, that my wife made me, says, math is not a spectator sport. It's not about watching somebody else do it. It's about what can you do on your own. Okay, so here in just a minute we'll need to go through that. So if I use my cover-up method, okay, I will end up with two equations. I'm going to try to write these both right here. 7 over 2x equals 14. Well, come on. Okay, 7 over 2x equals 14. And my second equation will be 2y equals 14. Okay, so if I solve each one of these, the first one, if I divide by 7 over 2, now notice that is the same as multiplying by 2 over 7. Okay, but if you type that in the calculator, it'll actually give you an answer, so you don't have to worry about that too much. And we should get x equals 4. Now, I've worked that out ahead of time, so be sure and type that in right now and check that. That gives me a point. Now, if you notice, they actually say right here, sometimes they'll be tricky and have these things swapped. But root is one of those words that we used, right? We had several words we could use for X Intercept. We had, well, X Intercept, root, 0. Let's see. No, we haven't seen any of those other words up to this point. But 0, solution, that's another one that we often see. Okay, but they will, like on the EOC, like to be tricky about that and throw out words that you maybe should know. Alright, so there's the root, the x-intercept. If I solve this equation, divide by 2, I get y equals 7. And so my y-intercept is 0, 7. So 4, 0, 0, 7. And there we have it. Okay, so at this point, I want you to pause your video, pause the video, attempt number 5, and then you can check with what I do. So, go. Okay, now that you've hopefully looked over this one, I'll see if I can work this one out a little bit quickly. 5x equals 30. 5x equals 30, so when we divide by 5 on both sides, I don't know if you can hear it, but I have Star Wars playing in the background. Haven't seen those in so long. Alright, so I get x equals 6, so 6, 0. For my second equation, I negative 3y equals 30. Divide by negative 3. Y equals negative 10. So 0, negative 10. Looking here, 6, 0. Okay, so I go to the right, 6. That point looks awful, but you can tell it's there. 0, negative 10, so we get down 10 down here at the very bottom of our graph. And if we connect those two lines, there we have it. Okay, so take a second, look at what you've got, check it. Do we have agree? Great. Okay, so hopefully the rest of these will go very quickly like a breeze. Okay, so if we cover up or we plug zeros in, we get negative 1/2 x equals 1. Now if we divide by negative 1/2, now be very careful with that. 1, if you divide by a negative, positive divided by negative is a negative. Okay, you should get x by itself. But if we say 1 divided by negative 1/2, actually if you think about this dividing by a fraction, it's multiplying by the reciprocal. So it actually comes out to be negative 2. Okay, so x equals negative 2. So negative 2 comma 0. And if we do the cover up again, we cover up our x term. We get negative y equals 1. Is y by itself? No, we have this problem. There's a pesky negative sign out there. Okay, so what I'm going to do is I'm going to rewrite that in there, but I'm actually going to write that as a negative with an understood 1. So we'll divide by negative 1. Negative 1, so y equals negative 1. Okay, so that gives us a y-intercept of 0, negative 1. And I really haven't been boxing these in because they're not really our answer. Our answer ends up really being our graph. But just know that there are 2 parts to every problem. That's why I'm doing these in 2 different colors. Okay, there are 2 parts to every one of these problems. So let's see, negative 2, 0. Negative 2, 0, 0, negative 1. Okay, now this is not asking this, but the slope here, just throw this back and come back to slope. Slope here is down 1 over 2. So down 1 to the right 2. So if I actually could, if I wanted to have a much more accurate graph, I could actually do that. I could continue in both directions. And so when I graph, give me a line. When I go to graph, it goes through all those points, which tells me my graph is pretty darn accurate. Okay, let's carry on. What's the phrase people keep saying? Keep calm and carry on. You know that comes from British history, right? Certainly. Certainly already knew that. Now, I love the shirt that said, keep calm and do math, because math is awesome. Okay, that is what I teach. I teach awesome. Okay. First one of these, let's see, we get to, for the X Intercept, divide, well, so for the X Intercept, I'm going to ignore that that's there. So I get x equals negative 4. Well, isn't that nice? Am I going to have to solve that one? Obviously no. Okay, my X Intercept is negative 4. For my Y Intercept, for my second trick, I'm going to ignore the x term. And so I'll get the equation 2y is negative 4. Definitely I'm going to have to solve that one. Divide by 2. Y equals negative 2. So 0, comma, negative 2. Okay, now hopefully you're starting to feel like an old pro at this. And so hopefully this is just extra information for you. But I am gonna do the rest of these so that you can have something to go back and look at later. Let's see here. I think, yes, that line will fit nicely. Okay. Okay. And let me make sure okay, good. Root, right there, that word root, of course. Word we keep seeing. Okay, that's really the X Intercept or the solution. or the 0. Thought I forgot, didn't you? Let's see. I feel like some of these are a little bit trickier, so I'm trying to remember which ones are the tricky ones. Perhaps I should flip my notes over. Alright, so for the X Intercept, I want to put in a 0 for the Y. So I'm going to cross out my Y term, and gee, that's a problem, right? That's not the Y term. Okay, this one is written not in standard form necessarily, so got to keep up with that. So for the X-intercept, I'm crossing out this one. I'm focusing on that right there. All right, so I'll get negative 9x equals 27, and yes, that is a 9. My 9s always look awful. I'll write it again just for you. You on the front row who asked. Divide by negative 9. Let's have a negative 9. And so I get x equals negative 3. So negative 3 comma 0. And because it's the X-intercept, I know that I ought to have a number in my X. Well, that didn't work out like I wanted it to. I know I should have a number in my X. For this ordered pair, I will have a number in my Y. I should have a 0 right there. So, crossing out the X term this time, focusing on the Y term, and I know that gets kind of messy. I'm just doing that to show you that I am covering up and using that cover method, really. Alright, so I get 3y. 3y equals 27. Okay, dividing by 3, I get y equals 9. So 0, 9. So I have negative 3, 0. And I have 0, 9. So up here toward the top. And that line's not going to fit. That might be pretty close. I just have to make sure that my 2 points are covered in that, and I make sure I have arrows on that. Okay, number 9. Okay, we are missing coefficients. That's the only thing that really makes this one any bit complicated at all. So we have an understood 1, so we have a negative 1x and a plus 1y. So our two equations end up being negative 1x equals 8 and 1y equals positive 8. So if I solve this one by dividing by negative 1, this equals negative 8. And so our 0 is 0, 8. I hope I'm not putting you to sleep with all this. Okay, this is, we're just kind of drudging on here. So, sorry. I'll try to think of a joke here in a second to tell you. Let's see, if we divide by 1, let's see, y equals 8. So our y-intercept 0, 8. And let's see, plot these points down. Let's do this in red. 8, 0. Now, wait a second. I made a mistake in here. Something doesn't feel right. I get a tingling in my hands whenever I'm doing math wrong. I left something off. Do you see what it is? That's a good check. That ought to keep you awake. Negative. I divided by a negative 8. I should have a negative 1, so I should have a negative 8 right there. So, negative 8, 0. That's what I should have right here. And 0, 8. You gotta check me. Okay? Even though I want you to trust me, you can't really just trust what anybody tells you. If you couldn't convince yourself, then don't believe it. It's really one of those things that math is really about. You just don't know about it. Okay, try number 10. Do that one on your own. Go. Okay, now that you've tried that one, I'll fly through this one. Negative 6x equals 36. Divide by negative 6. Now, I'll be honest, the more of these you do, the more they just kind of all blend together, and they just go really fast. Negative 6y equals 36, and perhaps I should draw a line down the middle of a negative 6. So y equals negative 6. Now, at first glance, it may look like we actually have the same point for these. We do not, because the x-intercept, or the root, always shows up in the x position, and the y-intercept always has a 0 in the x position, so they have a number in the y. So I have these 2 points. So they look similar, but they're not the same. We have negative 6, 0, and 0, negative 6. With a line connecting the two. If I can draw a line connecting the two. There we go. Close enough. Close enough for government work, as they say. Okay, so now we get to shift gears slightly into a word problem. Okay? We always have to come back and say, what does this mean? What does it mean for us? So the store sells socks for $2.50 per pair and shoelaces for $1.50. The equation 2.50 $2.50 x plus $1.50 y equals 30 describes the number of socks x and shoelaces y that you can buy for $30. Graph the function and find its intercepts. What does each represent? Okay, well, the first thing before I even think about graphing this at all, I really need to look at my Indiana Jones. I need to look at my graph and label it. So it said x was number of socks. So let's see. So x is always down here. Number of socks. And really that's pairs of socks. And then y is shoelaces, so let's do that. Number of okay, we'll see how we need to make the scales here in just a minute. Now, according to this, we have exactly $30. We have exactly $30. So, if we just wanted to buy socks, we would say, okay, they're $2.50 a pair. Forget completely about the shoelaces. $2.50 per pair of socks. So we just solve this equation. Solving equations should just be completely old hat at this point, right? You're all pros at it. But we always got to keep up to date on those skills, otherwise they just kind of fall off the wagon. So if I get that, I get x equals 12. Whoa. What happened to my pen? X equals 12, which as a point means 12, 0. And then second, if we have exactly $30 and we wanted to buy just shoelaces, well, they're $1.50 a piece. So we'd say 150y. Again, have to solve that equation. I keep running my 5s together. Okay, and so y equals 20, which as a point is 0, 20. Now, I'll come back to what that means in just a second, but if I graph this over here, 12, 0. Well, let's see. I feel like I need to label these. So if I need to get out to 12 over here, how about 2s? We go by 2s. Okay, so I start with 0 right there. Say 2, 4, 6, 8, 10, 12, 14. Then we're going up to 20 in the y direction, so I think we're going to actually go by 2s there as well. 2, 4, 6, 8, 10, 12, 14, 16, 18, and I'll just go ahead and put a 20 up there. So counting those by 2s. So I end up with a point at 12, 0, and a point at 0, 20. Okay, so if I connected those two, use my straight edge to draw that line. Okay, if I did that, put the ends on it. And the question is, what do those 2 points mean? Well, that is really easy now that we've actually got it graphed, because that point right there, I'm running out of colors here. That point right there is where you have 12 pairs of socks and 0 shoelaces. Likewise, that point right there is where you have 20 shoelaces but no pairs of socks. So all you bought was one or the other. So let's see if we can say that. This would be 12 socks, and it's kind of assumed we're talking about pairs there, and no shoelaces. Okay, and the y-intercept, as we said when we looked at this graph, is where you have 20 shoelaces but no pairs of socks. So how do we say vice versa? No socks, and 20 shoelaces. Maybe even a better interpretation here would be that that's when you buy all of one and none of the other. So if you decided you only wanted to buy socks, you'd have one of those. If you decided you only wanted to buy shoelaces, then you'd get the other. That's what that is. All right, so let's look at 12. We can actually probably interpret this one that way as well. So 12, last one. The concession stand sells nachos N for $3 and a slice of pizza P for $2. You have $12 you can spend on food, which is modeled by the equation 3n plus 2p equals 12. Graph the function and find its intercepts. What does each intercept represent? Okay, so if we take this equation right here, if I decided I only wanted to buy nachos, well, those are $3 a piece, right? Oops, I changed colors. If I only wanted to buy nachos, I have $12. That'd be 3n equals 12. So then, solving that equation, it turns out that I could buy 4 nachos. So I'm gonna come back to the point here in a second. I could buy 4 nachos. I could buy four sets of nachos, and that's really if I don't buy any pizza. No pizza slices. Okay. Likewise, if I said I want to go all in and just get all slices of pizza, $2 a piece, and I have $12. So common sense tells me I could get 6 of those. So that would be no nachos and 6 pizza slices. No nachos and 6 pizza slices. Okay, now I wrote it that way because we actually need to graph this. So I really need to know which one of these I'm going to treat like X and which one I'm going to treat like Y. It really doesn't matter too much, but I'm going to go ahead and just say we have nachos down here. You could do this the other way and it would be perfectly fine. Nachos and pizza. I don't know if I can do that. That is pizza. Alright, so if we said we only bought one, we had, well, let's say we had no nachos and 6 pizza slices, so let's scope these, let's just say by 1. So 0, 1, 2, 3, 4, 5, 6. Let's see, we're going to get to 4 over here. 4 for nachos. We can still go by 1, 0. 0. 1, 2, 3, 4, 5, 6. Okay, so we said no nachos, 6 pizza slices. Or 4 nachos. And there are a few combinations you really could get in there. Alright. So graph it, find the intercepts. What does each intercept represent? So in our case, because we labeled this with as X as nachos, Y as pizza, our points, the intercepts, are actually 4, 0 and 0, 6. Alright, keep calm and carry on finding your intercepts. Out.